My name is Muriel Medard. I'm co-founder and CEO of Optimum, which is decentralized memory for the world computer. So very aligned philosophically with some of the other things we've heard. This is where I come from. I left MIT to do this full time. At MIT, I held the NEC chair for software science and engineering for the entire School of Engineering. I have been working on this for 20 years. So this is something, the resilience, decentralized management of data is my passion, has been my entire career. Let's go back to what the world computer is, you know, when we talk about building the world computer. So right after World War II, which is really when, you know, we started thinking in a principled ways of computers, by computers, von Neumann came out with this architecture, sometimes called the Princeton architecture, and basically said, okay, what does it mean to be a computer? You have effectively three things. The compute and arithmetic logic, so that's what we think of the compute in computer, which of course, you know, you need the input and output, which we can talk about later. And then you have the memory. And the memory, you have to access it through the bus. So anyone here who has ever put together their own computer, you know this, right? You had to get a bus, you had to decide what memory you used, you had to decide, you know, what CPU you used, and those are the components. Now, if you look at the top part, that's kind of like the top part of the web stack, it kind of looks pretty reasonable. So if you look at what we have in Web3, and you look at, you know, what we would learn in a computer architecture class, it looks like, you know, it all jives. You have an operating system, maybe EVM, SVM. You might have some that are non-Turing complete. You can't program everything you want, but, you know, you can program what you need. And then you have a variety of applications running on those OSs. Okay. So far, so good. Now let's look at the bottom part. The part with the bus and the memory. That doesn't look at all like, you know, anything that a computer engineering class would do. You have really ad hoc solutions for read-writes. You have things like mempools. So, you know, if you think of basically memory as being your closet where, you know, you put in clothes, you take them in, you take them out, and they should be, you know, in there if you left them in there and not in there if you didn't put them in there. Mempool is like, you know, a laundry pile on the floor that you have to rummage through every time to find out what's in there. You have full nodes that are basically a closet that has everything, including up until your baby clothes. You know, and then we have gossip, which is very, very slow, which is not at all like what a bus would look like. So you have a really, really complicated ad hoc set of techniques which don't look like a well-ordered bus and memory. So why do we care? So what? You know, so what if it doesn't look like what we learned? Well, we care because things become expensive. They're sluggish. You have scaling challenges, right? And therefore, you know, it's not just about being principled. It's about what you're getting by not being principled. So what do we do in a completely decentralized setting, not just distributed, but fully decentralized? We use coding, so we use algebraic techniques, which I co-invented, which were developed in my lab, and we use them to optimize, hence the name of our company, to entirely optimize the behavior in the bus, so basically in the propagation. And why do we do that also? We do that because then you can go from that to the also Optimum DeRAM, so the decentralized RAM, where we're able to have the atomicity. That's to say that, you know, a piece, every piece of data is completely respected as an atomic entity. Consistency, you don't have reordering ever happening, and durability. You know, the data is there for as long as you put it in. So who benefits from Optimum? Well, we have basically validators and L1 and L2s. We speed up block propagation optimally. You cannot go faster than this over any topology, over whatever resources you have available. And for the DRAM, we basically have, again, coding optimizing the utility of our RAM. We're launching next month, so just in a few weeks, our testnet. We would love to hear from you, particularly if you're node operators or projects that use node operators very directly. And we're releasing our research papers. Please follow us on X and look for some very exciting announcements this week. Thank you very much.
Yeah, and with